Hello, everyone, and welcome to the SCMH Awareness webinar with this focus topic on the SCMH 2.4 Special Characteristics Selection and Control. I would like to invite Steve Webster with Collins Aerospace, who is the project team leader for the group, to begin the webinar. Steve?
Hi, everybody. Thanks for attending the webinar. A couple of things. Before we start, I want to highlight three areas that we need to consider here for the best experience. One is computer housekeeping to close all unnecessary applications to ensure that you have enough bandwidth and don't have any technical issues affecting your ability to see or hear the webinar. The second area would be the way we want you to submit questions would be through Q&A, not through the chat. So there's a Q&A icon up on the top on the ribbon, but you should be able to see that. If you have any questions, we recommend that you submit them through there. And the way we're going to handle the questions is we're going to try to get as many questions in the span of this webinar, which we may get more questions. If we do, we are planning on having a podcast in the February timeframe, and we'll address any questions that we didn't get to here during that podcast. From there, we're going to talk a little bit about how to, for those of you that may not have a lot of experience with navigating through the IAQG and getting to the Supply Chain Management Handbook, which is the acronym SCMH. One of the way you want to do that is when you want to go to IAQG.org, and when you get to IAQG.org, you'll see the graphic that's on the screen right now. And there's two ways to get to the SCMH. One is through the SCMH on the top ribbon. If you click that, you'll get directly into the SCMH. The other path is to go into IAQG Tools. And once you click on that IAQG Tools on the lower ribbon there, a pull-down menu will come down, and you'll be able to pick SCMH off that pull-down menu. Going to the next piece here is once you get into the SCMH, this is the SCMH landing page, and on the graph that's on the upper left, that's the landing page. That's where you're going to end up. And in that landing page, you want to click on SCMH topics. There's two ways to get to where we want to go. One of them is to click on the SCMH topics ribbon at the top of the page, or you can click on the Design and Develop chevron. You can see where the two circles are there with the red arrows. And if you click on either one of those, and you'll end up in the SCMH Design and Develop landing page, which is down at the lower left. And for the purposes of making this a little bit easier to see, we zoomed in on it, and that graphic on the right shows you where we are with our guidance material. And you'll notice that the title of the webinar is Special Characteristics Selection and Control. And once you're there, you can hit the plus button. And once you do that, it'll expand out, and you will see some links to the guidance material. And there's probably going to end up being a link to the webinar, and maybe there'll be a PDF of the webinar that shows up there at some point. And we have a maturity matrix, which is in work. I think there's some notes in there for that. So once you get there, you can go to that, and then from there you can click on any one of those. And the thing is what we want to tell you is that you can download the material at no cost. But if you've already been in here and you've got an ID and everything, you can get in there and just put your username and log on, your password in there, and then you can download any of that material. If you're new to the SCMH, there's on the pop-up that shows up when you go to log in, there's going to be a button that that asks you to register if you haven't been in the SCMH before, and then you'll end up having to fill out some information the IAQG doesn't want to charge you for anything. They just want to make sure that they have an understanding of who's, working inside the system and keeping track of everything. So that's the part, the upfront main, just how to handle and navigate the SCMH. Now we're going to get into what we're here for, and what we're here for is, of course, special characteristics selection and control. So in this webinar, we will be looking at how 9100 interprets critical items and key characteristics, and spend some time on what special characteristics are, which is a new term. We will get into that in a little bit too, and walk through each of the characteristic types. Our team, we've got 4 presenters, and we're going to kind of have different presenters walk through the different types, and then I will come off at the end and we'll talk about, we have a summary of the event at the end of the presentation. And just for, we put this is what the actual the guidance document front page looks like if you go in there and you pull it up. So from there, I'm going to go to the next slide here. And what I'm going to do, and I guess I have to play this game here where I have to hit this guy here so you can see my I guess, does that matter? Yeah, you can see me now. I'm Steve Webster. I am a senior fellow at Collins Aerospace, which is part of the RTX organization. And I'm, as far as the IAQG goes, I'm on the AS, or actually the 9145 team, the writing team, and the deployment teams. I'm also, as mentioned earlier, I'm leading the effort here with a fantastic group of people that I've been working with on the special characteristics selection and control guidance. And with that, I want to introduce Raluca. And Raluca, could you please, let people know a little bit about yourself?
Sure. Hello, everyone. I'm Raluca Dimitraki. I'm an associate technical fellow with the Bowen Company. I'm part of the core writing team for Standard 9145, and I also lead the deployment teams for phases 4 and 5 for Standard 9145. Eric?
Yeah, good morning. Technical difficulties with my picture, but you're not missing much. My name is Eric Prather. I'm at GE Aerospace as an advanced quality leader, so focusing on APQP and zero defects. And I've been supporting this team for a few years and support the 9145 phase 3 deployment team. Soren?
Yes. So, like this. So, hello, I'm Soren Knuts from GKN Aerospace, Sweden, and I'm a specialist in risk management, robust design, and Six Sigma methods. And I have contributed also within the design risk analysis team, as well as the risk management team 7.3. And now over to you, Steve.
Thanks, Soren. I'm not going to leave this slide without mentioning there's been a lot of people that have contributed to the content here, and this team has been around for close to 4 years. This is a tough subject, which I want to mention that the project was initiated. Well, there were many, and one of the things, there were many twists and turns and starts and restarts with this. I mean, I learned a lot about a lot of different things that I wasn't aware of. There's a lot of people here have a lot of horsepower, and all these starts and restarts and everything got us to where we are today, where we actually have a released document that we are able to do a webinar with, which back a few years ago, I was questioning whether or not we'd ever make it that far, but we've gotten to that point, and it's very difficult to get all the different organizations in alignment on these things sometimes, and we have to come up with a some compromises and common ground for everybody. And we're hoping that this guidance document gets us to where we all are on the same page. And all of the contributors mentioned on this page have added value to that effort at one point or another, and I want to make sure that they get recognized for it. And with that said, we'll go to the next slide. And as far as the learning objectives go, this project was initiated to produce a set of common terminology across ASD and avoid improper use of critical and key characteristics, which has been a challenge. When I say ASD, I'm talking about aerospace and defense. It's a little acronym that we have here. And I want to say that there's been a lot of challenges. And personally, I work at Collins, as I mentioned earlier, and we're both a customer and a supplier. So I get some of these challenges, not only from being a customer, but also being a supplier to some of our customers. And we've had some challenges with how we handle some of this stuff. There's been a lot of confusion around it over the years. And some of the term, what we're doing here with the guidance is we've got we're going to deal with some existing terms, and we've kind of come up with some new terms that we're going to explore as we go forward with, through the slide deck here. And we will discuss requirements flow and what it looks like. We're going to then highlight how the different special characteristic types play together. And from there, Soren, Eric, and Raluca will dig into each special characteristic type in a systematic fashion where we have a definition, a selection, and control kind of a script. And next slide here. Here we have a graphic that is a 9100 interpretation. And what that graphic is, it's on the left there, and it shows the KC-CI relationship that identifies KCs as a subset of critical items, and meaning that you must have a critical item to have a KC. That's been kind of a little bit of a challenge over the, at least in my experience. And the things I want to touch on here is that special requirements, which is the top balloon up there, and critical items and KCs are related, but they're not independent, which we'll see in a second. And some of the issues that we've had, with, some misalignment around that concept of the 9100 interpretation is, there's been improper use of the characteristics in selection. And once you've committed, at least in my experience, once you've committed to putting product characteristics in the design definition, it's very difficult to get them out. And we've had some, we've had to create some workarounds to try to deal with that. And, you don't want to have a bunch of these characteristics on your design definition and then have to have, waivers or deviations to try to not, to try to, handle some of the challenges with them not being selected properly and that kind of stuff. And the other thing too is even when they're on there, on the other side of the coin is overreactions and wasted resources and non-value added actions. We don't want to have a large quantity of critical item or critical characteristics and key characteristics on our drawings and models unless they actually are going to add value. And by not having proper understanding of which ones are the right ones to put on there, we run into, waste and non-value added activities where we could spend that effort on the things that really need it. And from our point of view, the problem has been there's a lack of unified terminology around the different types of characteristics and little guidance on how to select and manage them. And our mission was to try to kind of fill that gap with what we're doing here. Next slide. And so in this case, the term special characteristics is a new term for aerospace and defense, and we've introduced it in this guidance. I think this is probably the first place where it's been introduced in aerospace and defense. Special characteristics is inclusive of all characteristics that require specific actions beyond the standard quality control requirements that are typical in the way we manage things. And this term we're using to provide a level of organization to tie the characteristics for the characteristic types, to tie them together. So for clarity, because the big challenge we've had here is the confusion around how to handle that. And, you know, so that's kind of where we're at with that. And we're using it as an umbrella term, which you'll see down on the next slide. Okay, the table at the top shows the hierarchical view of the levels and lanes of the special characteristic selection structure, and allows the user to quickly see how the content is organized from the requirement level all the way down to the characteristic level. And if you look, it's up on the top here. You can see that we have levels and then we have lanes, and we're going to primarily focus on these 3 lanes: safety, essential, and critical characteristics, as part of beyond, you know, when we get into the continuing this webinar here. And I want to mention too that special characteristics, the term is needed. Yeah, I guess I kind of went through that. The term is needed to capture all this. I think I'm on slide 10 here too. So the 9100 interpretation presented earlier, which was that slide where we showed the nested key characteristic inside the critical items. There are gaps in the hierarchy of the special characteristics guidance, you know, of the whole structure of this, where we, as a team, we noticed that there were gaps, and the table above here was intended to kind of fill the gaps to make sure that, you know, everything kind of had its place. And with the next slide, we're going to delve into detail at the characteristic level of the hierarchy. Both this table and the relationship graphic on the next slide should give a complete story on the workings of the special characteristic selection process. So this table here kind of gives you the structure, and this area here, this slide is going to kind of give us, you know, an idea of how they're related. And before I get into looking at the graphic on the left, I'm going to talk a little bit about the safety and essential characteristics are driven by severity, and key characteristics are driven by variation. There's a definite demarcation here where when we talk about safety and essential characteristics, they're really primarily severity and impact based, where key characteristics are driven by variation that may be inherent in the process. And the idea of that is to try to, you know, control variation. And then from there, you know, we have safety impacts. And when we talk about safety impacts, we're talking about things like injury, fatality, or loss of aircraft. So those are, you know, really important from a severity point of view. And then we have non-safety impacts on the essential. We're going to introduce a characteristic called an essential characteristic, which is a non-safety, but, you know, important characteristic that may include financial and operational consequences like flight aborts, flight delays, AOG, aircraft on ground, stuff that, you know, is operationally causing pain to an organization. And then some regulatory consequences, which we may suffer penalties or fines or whatever. Those may fall under an essential impact. And then in certain, you know, we get into, you know, the characteristics. If we look at the figure on the left, the relationships We see that there's overlap with key characteristics that it has with both safety and essential characteristics. So if I go over here and I look at over on the left here, we've got the red circle is safety and the salmon colored circle is essential, and then we have key. You'll notice that these two don't connect to each other, but they both have the ability and overlap with key characteristics. And what that implies is that you can have a safety characteristic which is going to have its own designator, and you can also, that safety characteristic may benefit from variation management, and which would then, involve adding an additional, symbol or designator for a key characteristic. And the same can be said for essential. If you have, like what I mentioned earlier, where you have financial or operational or regulatory consequences that don't come up to the level of, a injury or fatality or loss of life, those can also will have their own designator or symbol, and then you would have a key. If there's variation management, could be added to that. They're not mutually exclusive per se. And then the last thing I want to talk about here is, furthermore, this overlap shows the possibility that safety and essential characteristics can also have a benefit from variation management and the application of a key characteristic. So treat them, they're different, but they there is a possibility that variation management could be a benefit in those cases. And then from here, I want to introduce Soren, who will further explore safety characteristics.
Thank you, Steve. So, basic, next slide. Thank you. Yep. So, basically, safety requirements are addressed through aerospace standard safety assessment processes like functional hazard assessment that influence the design to ensure that safety requirements are properly addressed. The safety assessment process is iterative and highly integrated with the design process as the design is updated and reassessed. The design process also identifies if any part of the design will be allocated to suppliers, in which case the requirements activity will be repeated for the aspect of the design. Note that in the definition where we reference to standard 9017, where a combination of critical item safety and critical characteristic have been used, we have decided to use the following definition. A safety characteristic is a design characteristic that, if missing or non-conforming to the design data, quality requirements, or overhaul and maintenance documentation, would result in an unsafe condition. So next slide. Thank you. So the safety characteristics and selection. So the selection process following from a performed requirements activity and is mainly driven by two different in parallel product activities, design risk analysis and safety assessment process, where both processes can inform each other on design risk with safety impact. However, safety assessment process will decide on and identify safety characteristics, and that you can see by the red boxes that we have marked on the lower part of the process described. And note also that the IAQG tools to be used that are DRA, DFMEA, PFMEA, and the control plan. So next slide, please. So safety characteristics control. As previously shown in slide 11 that Steve showed, there is an overlap between safety characteristics and key characteristics. But the main control strategy is specification control by 100% value check for a product safety characteristic. And frozen safety process management, that also means that no material review board, MRB, is allowed. This is also valid in case of process safety characteristics and are tied to product safety characteristics. And now over to you, Eric.
Hey, thanks, Soren. So essential characteristics are next. Conceptually, this is kind of the new thing. And I say the word conceptually with intent. So essential is not a term that you'll see anywhere, right? You might already have this idea within your company that we have this essential characteristic that is, it's important, but it's not quite safety. And so that's the big focus here. So essential requirements, we're going to look through mostly our design risk analysis process, and we'll get to that in a second, but that's going to help define, these are things that we really need to focus on, even if they don't have a safety impact. So jumping to this bottom bullet, right, the dictionary definitions around essential, indispensable, urgently needed, right? These are terms that you might use to describe this characteristic, whatever terminology you use in your organization to define this. But really it's mission critical, it's dispatch critical. These are things that are going to have an impact on the function of the part. It might have regulatory impact, but these are definitely things that we have to pay extra attention to, and we have to put extra controls in place to make sure that we are successfully managing them. And Steve, if you can go to the next slide. So the selection process, this mirrors what we just saw with safety. So we're going through the top lane here though. We're looking at design risk analysis. So these haven't been flagged as safety relevant, but in the DRA, we've determined these do have a big impact on our success, right? And that we have to manage these. So as we flow through from left to right, we go from those requirements flowing in to item selection and all the way down to those characteristics being selected. And that's what we want to focus on, is how do we use the characteristics when we get down to that level? Down at the bottom, we have those related tools. Again, we're looking at DRA and DFMEA to define what are our essential characteristics. But once they're defined, in the PFMEA, we want to highlight these are essential. These are important to us. We already mentioned earlier the link to severity. There's not strict guidance around where that is, but these are things that are going to be more important when we look at that. And then finally, in the control plan, we want to highlight this is an essential characteristic. Here's how we're going to manage it. We're making it this way. Here's how we're managing it to make sure that we don't ship bad product. And then Steve, if you want to go to my last slide. Yep. So control strategies for essential. Product and process, right? Product, we tend to look at outputs. Process, we tend to look at inputs. So these are, for product, we're assigning these to the non-safety characteristics that engineering has deemed important. And then for process characteristics, right, maybe it's a substitute, maybe we can't easily manage the output, but we manage the input, but we want process control tied to an essential characteristic or a COPQ initiative. For control strategy, that's very similar to safety, right? Again, we're not focused on variation yet. That's going to be a part of key. So for essential and for safety, we have the same control strategy of we have to be in spec. Recommended control methods, anytime we can do some improved sampling or mistake proofing is ideal. Right? Mistake proofing always the best solution, right? Let's not make bad product. And then for those process essential characteristics, we want to measure those process characteristics to ensure we're always within those limits based on statistical analysis or whatever type of study we've done to support defining those inputs. So that's essential characteristics wrapped up. Again, remember, this is just kind of a broad term. You might call it something different, but I will send it to Raluca to talk key characteristics.
Thank you, Eric. Okay, let's talk about key characteristics definition. The IAQG standard 9100 defines KCs as being an attribute or feature whose variation has a significant effect on product fit, form, function, performance, service, or producibility that requires specific action for the purpose of controlling variation. What differentiates KCs from the other types of characteristics is the significant benefit when the characteristic is produced at the specified dimension or nominal value rather than just within tolerance. IAQG standard 9103, titled Variation Management for Key Characteristics, further defines KCs into product and process and ties process KCs to product KCs by stating that control of process KCs is essential to manage variation of product KCs. The same standard also defines substitute key characteristics, which are defined or identified when a customer-defined KC is not readily available in the manufacturing environment, and other characteristics need to be controlled to ensure conformity. Finally, 9103 states that KCs are measurable features of a product or characteristic of a manufacturing process. Let's take a look at the selection process for KCs. Next slide, please. All right. Similarly to the selection of safety and essential characteristics, we start with a set of requirements. So going from left to right on this slide, on this process flow. A preliminary list of key characteristics is created from similar product reviewed for historical sources of variation. Then, as part of the design risk analysis activity, or DRA, variation analysis of variation sources is performed to assess the risk to meeting requirements. The contributors to variation form the list of what we call candidate key characteristics. Then these candidates these candidates are taken through a design and process FMEA activities. The result from the variation analysis is used to inform the occurrence ranking on the design and process FMEAs. So based on outputs from variation analysis and FMEA, design is optimized to eliminate or reduce the sensitivity to variation, if at all possible. It may take several iterations of the design to eliminate or reduce variation. The list of final KCs contains those characteristics whose variation cannot be mitigated through design iterations, and therefore require control in order to manage that variation. And then finally, KCs are incorporated into design definition. A really important thing to note here is that the goal is to have no KCs. Now, what do I mean by that? We should strive to eliminate variation from our designs and manufacturing processes. And if we're able to do so, then we won't need KCs. Let's take a look at control of key characteristics. Next slide, please. Okay. When it comes to control of key characteristics, statistical process control, or SPC, is the preferred method for variation management. And there are two requirements that need to be met when SPC is chosen as the method for control of key characteristics. The first is that the process needs to be statistically stable and capable. And the second is that process capability index, such as CP and CPK, can only be established when process is shown to be stable and statistically in control through the use of control charts and or statistical methods. And with that, I will turn it over to Steve, who will summarize everything we've presented in this webinar. Steve?
Thank you, Raluca. Okay, well, we've thrown a lot of stuff out here in this webinar in a short period of time. So I'm just going to kind of walk through what the outcome, what our intentions were. We introduced a new approach for, defining, selecting, and controlling special characteristics. I know the title of the guidance says selection and control of special characteristics, but we initially, when the group was put together for this project, it was originally a defining project, and what we did is we expanded the scope of what we were doing to include defining, selecting, and controlling. And in the end, selection and control was the ultimate, strategy that we wanted to make sure, because a lot of the issues that we've had in aerospace and defense is picking the right characteristics and understanding categorically how to handle those. And in this case, we've created an essential characteristic, which we have talked about as a kind of a new term. Safety has been around; it's covered in a lot of different standards, and key is also covered in, as far as variation control goes. But those are the three, as I say, lanes that we are going down when we get involved in the selection and even the control process. So we've also introduced a hierarchical approach to clarify requirements, items, and characteristics in such a way that you can take a look at what we've done and see, how that how the hierarchy looks. And in the past, trying to put a hierarchy together like that has been challenging, because the critical item versus critical characteristic and key characteristic, there seem to be some puzzle pieces missing there. We've tried to help with that. We've highlighted the relationships between the different characteristic types. I mentioned, I think it was at slide 11, where there's a level of independence with these characteristic types, but there is also a level of overlap between critical, safety characteristics and key, and essential characteristics and key, which we showed earlier. So that's pretty much what we've been going through in a nutshell. And then just so everybody knows, I know I talked up front on how to find section 2.4, but what we've done here is we've actually put a link that takes you right to section 2.4. And if you follow the guidance that I gave you on how to get into the SCMH earlier in this presentation, you shouldn't have too much trouble getting in there and taking a look at the guidance. And I also want to, I know I mentioned that we spent a lot of time going back and forth and trying to sort all this stuff out over the past almost 4 years. We did spend a good part of that time, once we got what we think we needed together, to develop examples. So in the guidance material, we have, I believe, 5 examples that highlight scenarios for how you would apply each type in different situations. And that's at the, there's 25 pages in the guidance material itself, and then the appendix takes up the rest. And I think there's over 50 pages. So we've got a lot of information in the appendix that, don't just, go and look at the guidance material. Take a look at what's going on inside the appendix. And I think I know for a fact, every one of the characteristic types is covered in an application in the appendix. And finally, to assess the link and download the guidance, like I mentioned earlier, get registered. It doesn't cost anything, and there's a lot, and it's not just about what we're doing here. There is a lot of information in the SCMH, and it's put together by, you know, a lot of smart people getting together to make sure that, you know, our aerospace and defense has a place to go and find and learn and get better acquainted with some of the topics that we're covering. With that, I think that's pretty much the webinar. With the now we're going to get into the live Q&A, and I'm gonna turn over to Raluca. So
Okay,
Raluca,
yes. Yeah, we have quite a few questions here. And let me just start with one. First question is, should every drawing have at least one KC? I think I can answer this one, which I think I've already answered when I was presenting the selection process of key characteristics. So the answer is no. We want to strive for no variation in our designs and manufacturing processes. So we do not want to have a KC on every drawing. That's at least what we should strive for.
Yeah, and I'm thinking, like, when you say we don't, should every drawing have a KC, I can just give you my experience back early, maybe, I don't know, I'm not going to date myself, but we had this mission early on that, you know, we had to get a quota of KCs to actually say that we have an effective design. And the reality is the objective, as Raluca had mentioned, is we want to design variation out of our products so that we don't have to manage and control them with KCs. So it kind of fits, and I know, Raluca, you mentioned that. So that's and so don't be looking for quotas. Is really what it's about. It's about, you know, follow your DRA processes and, you know, use our guidance to help you with that. So that's my 2 cents on it anyway. I don't know.
All right.
Want to go to it?
Yeah, let's get another question. So it, are critical items always safety related? Eric, I think you might want to answer this one.
Yeah, so the definition of critical item, right, breaks down into our two different characteristic types of being a safety item or an essential, or sorry, a safety characteristic or an essential characteristic. So critical item is kind of in that hierarchy of one step above the characteristics, where it could be either one of those two things. But all critical items are special all characteristics derived from critical items are special characteristics.
Okay. Next question is, this guidance does not get into specifics regarding the identification of these characteristics into product definition. What is the recommendation from the industry on these? Steve, do you want to answer that?
Yeah, I'll take a shot at it. It was never intended for the guidance to get into specific detail on critical or key characteristic symbols or designators. The recommendation from our group, you know, our project team, is that each organization should be responsible to use their own symbols and designators at their discretion. Our main mission was to get to take care of the confusion and at a higher level. But where the rubber meets the road, it's really on the companies to deal with those symbols and designators.
Yep. Okay, next question is, how do I implement process key characteristics? That's a really good question. I'll take a stab at it. So there are several approaches to this. I'm going to briefly talk about one of them, and maybe my teammates can provide another examples. The definition says that a process KC is a measurable characteristic of the manufacturing process whose control is essential in managing variation of product key characteristic. So one approach is to always tie a process KC to a product KC. So for example, if the hole diameter is a product KC, Then through the selection process of the process KC, you may discover that drill speeds and feeds are process parameters that need to be controlled in order to manage variation of the product KC. One approach is to always tie. There will never be a situation where a process KC will exist without a product KC. And I think, Eric, you may have an example of a different approach for this.
Yeah, we had a lot of discussion within our team on how to handle this, and people are doing things a little bit differently. I don't want to name names, but I've seen a lot of organizations doing a lot of different things. And one additional application that I've seen, rather than being linked to the product KC, is the implementation of a process KC in order to maybe reduce scrap or some other internal control where it's necessary to manage that process KC. We also see it around in-process characteristics sometimes, where we can't control our final output, so we have to manage it before we kind of get there. We see that maybe with coatings, where we're adding a thickness, and the coating thickness is stable enough to where we really have to manage that machined diameter maybe before we get there to manage our final output. So that's another time we might see a process KC. So there are a lot of different applications there, potentially, right? But the idea is, again, how are we managing the variation of our inputs to better control our outputs is big picture what we want to drive to.
Thank you, Eric. Okay, next question is, why introduce essential characteristics? Steve, do you want to answer that?
Let's see. I think I can try to answer that one. That's a really good question. So I know it's a term that we've introduced here. So I'm going to say that the reason we introduced it was to provide a category for non-safety related characteristics that would require specific actions beyond what we would normally do. Like I think I mentioned it earlier in the webinar, that doesn't currently exist generally in aerospace and defense today. And when I say what we would do generally, it's like the routine inspection activity that we would normally do. What it is it's kind of a middle of ground area where you've got high impact, but not high enough to get you to a safety situation. And we felt that, that was a missing component of the whole process. And by identifying that, we've maybe helped out people to fill that gap. So that's where I'm at with that one.
Thank you, Steve.
Yeah.
Okay, next question is, will this guidance become part of standards? Good question. I think I can answer that question. Not for the foreseeable future. What we really wanted to communicate with this guidance is the concept behind these different types of characteristics. So essentially the intent behind them. This nomenclature for essential characteristics or special characteristics already exists or may already exist in the industry, and this specific nomenclature may be used with a different intent, and that's okay. What we call these characteristics is not really important. What's important is the concept behind them. So there are no plans for the foreseeable future to make these part of a standard, but guidance to the industry on what the intent is behind these. Good question. Okay, let's see what other questions. Next question is, on KCs, what is the CPK value for a stable process? Is it 1.33, 1.67? Steve, do you want to take this one?
I can try to take that one. Oops, sorry. Get this video thing here. I mean, just from my experience over the years, 1.33 would be for production and 1.67 would be for development. In general, you would look to strive for a 167 CPK as part of, oops, I got something coming up here, sorry. In my experience, the 167 was really, when you're in the development process and you're doing initial capability. And once the tooling is, at a steady state, then you would go to a 1.33 CPK. I know there's different probably ways that people do those things, but that's what I've seen in my experience.
Thank you, Steve. Okay. Next question. Is there an update expected to AS 9145? Yes, there is. It's very much in work. We are hard at work on releasing a new version of 9145. And we're currently going through resolution of comments from the last ballot review. So yes, 9145 will, I don't know what soon is maybe 6 months, because the release process takes quite a bit of time. But a new version of 9145 is in work. Other question is, has our community in SCMH considered using MBSE in KC development? In other words, the application of MBSE that focuses on manufacturing requirements for control and include an INCOSE or using INCOSE principles. It's a very good question. I think at the SCMH, I'm not aware of any discussions at the SCMH level. But teammates, are you?
I'm not aware of anything within the SCMH, but there may be some in the design and development area. I might have to take a look and see what's going on in there.
Yeah.
And I think when we say MBSE, we're talking about model-based systems engineering, just so everybody
Correct.
knows what that acronym is. I know a lot of our companies are doing that, so.
We, in the design risk analysis guidance, MBSE was anyway mentioned.
Okay, so there's
we
one
should
place
adopt
where it
to.
was mentioned. Yeah, and I know it seems to be the norm nowadays. I'm actually involved in model-based definition, and we have MBDMI, which is model-based design, manufacturing, and inspection. So I'm on the quality side of it, so I'm dealing with a lot of what we call MBI, which is model-based inspection activity. So that's seems to be the new, it's gaining momentum and gathering steam, so to speak. So I'm sure the SCMH is going to have, is going to have to get into that space at some point in time.
Yep. Okay, I think that completes the questions.
So Raluca, I can see from the very last question that was put to us, if we will share the presentation. So I guess we will put the presentation at the SCMH page.
Yes. Yeah, the
Together with
presentation as well
recording.
as the webinar, the recording, they will be published on the SCMH page where the guidance material is published.
And I can also see with the Q&A here that we have a lot of questions that we still haven't answered to. So maybe we will put also the questions with answers afterwards.
I think we're going to end up taking those to the podcast.
Yes, yeah, exactly.
Yep.
Every question that we get, we will answer in the podcast, which will be released sometime in February.
And so stay tuned for that. If you didn't get your question hit here, we'll hit them then.
Yeah.
And
Great.
I guess if there are no further questions, I think it's a good time to say thank everybody for attending, and hopefully you benefited from this webinar.
Thank you, everyone.
Thank you.
Thank you.